Good morning, students. Today our topic is applications of first order differential equation. Exercise 10.8 first problem. The rate of increase in the number of bacteria in a certain bacteria culture is proportional to the number present. Given that the number triples in 5 hours, find how many bacteria will be present after 10 hours. So to solve this, we have to do 5 steps. The step 1, read the question carefully. From that, you have to form the differential equation. So second step, you have to solve the differential equation. That means you have to write the expression in terms of independent and dependent variables. That is, you have to write the expression in terms of x and y. Third step, you have to apply the initial condition. Fourth step, what is the condition given in the problem that has to be applied. And the fifth step, what is asked that has to be found. So using 5 steps, we are going to do the problems. See the first problem. The rate of increase in the number of bacteria in a certain bacteria culture is proportional to the number present. So first we need variable. So here I have denoted, let x be the number of bacteria present at time t. So what is x? X is nothing but the amount of bacteria, the number of bacteria at time t. Okay, so see the first word, the rate of increase. So the rate of increase of in the number of bacteria. So the number of bacteria we have denoted as x. So the rate of increase of x. So in the chapter, 7th chapter, that is in the differential calculus, we have studied about the rate of change. Rate of change usually with respect to time. So here also the same thing you have to use. The rate of increase of number of bacteria. So that is x, the rate of increase of x. So you have to use dx by dt. So you have to use the first derivative with respect to time. So dx by dt. How it is? It is proportional. So I use the symbol proportionality. So proportional to the number present. How many? It is x. So from the first sentence we formed the differential equation, that is dx by dt is proportional to x. So we have to remove the proportionality. So it is equal to k into x, where k is the constant of proportionality. Okay, so this is the differential equation. Okay, so your first step we have completed. Second step, what you have to do? You have to solve the differential equation and write it in terms of x and y. So for that I am using the variable separable method. So in the right side x I have brought to the left side. So it will be brought to the denominator. So dx by x, and dt, where it will be gone to right hand side in the numerator. So dx by x is equal to k into dt. So see the left side you are having x variable, and the right side you are having the t variable t. Okay, so you have to integrate on both the sides. So integral dx by x is equal to integral k into dt. So you know that integral dx by x is nothing but log x, and integral k is a constant. So integral dt is t plus c. So c is the constant of integration. So the log, when you take it to the right side, it will become exponential function. So therefore e power kt plus c. So here the power is, it's in addition. So we can split as e power kt into e power c. Okay, so the base was same. If you want to multiply, you have to add the power. So the power is added here. So we can separate it, e power kt into e power c. So therefore x is equal to, e power c is a constant. So we can denote that constant as c. Okay, c e power kt. We solved this differential equation and find the solution. Second step is over. What is third step? You have to apply the initial condition. So see that the initial condition is when t is equal to 0. So initially, so when t is equal to 0, what is your x? The x is nothing but number of bacteria. So it is not given. Okay, so when t is equal to 0, we have to take the number of bacteria present when t is equal to 0 is x naught. X naught is the initial amount of bacteria. That means when t is equal to 0, x is equal to x naught. So this has to be substituted in the first equation. So what is x? X is nothing but x naught is equal to c into e power. What is your t? T is 0. K into 0 is 0. So you are getting x naught is equal to c e power 0. You know that e power 0 is 1. So c is equal to x naught. So the c value has to be substituted in 1. So x is equal to x naught e power kt. So one constant we have found, that is c as x naught. Okay. So you mark this expression as 2. So what is the fourth step? What is given? That has to be given condition has to be applied. You see that the second sentence, given that the number, what is number? The number of bacteria triples in 5 hours. So 5 hours, it is time. So when t is equal to 5 hours, the number of bacteria triples. Triples means what? Initial amount, it will triple. So what is the initial amount? It is x naught. So when t is equal to 5, the number of bacteria is equal to 3x naught. Okay, so t and x has to be substituted in the second equation. So in the place of x, you have to substitute 3x naught is equal to x naught e power. What is t? T is 5. So it is 5k. So x naught getting cancel. So 3 is equal to e power 5k. So given condition also applied. You see the question. So see the third sentence. Find how many bacteria will be present after 10 hours. So after 10 hours means when t is equal to 10 hours, how many bacteria will be present? So we have to find x. So to find x is equal to what? When t is equal to 10. So where you have to substitute these results, you go to the second expression. In that, in the place of x, you have to substitute x. That only you are going to find the x naught. X naught has to be written e power. What is your t? 10. Okay, so e power 10k. So the e power 10k can be written as e power 5k into e power 5k. You see that base are same. If you want to multiply, you have to add the power. So 5k plus 5k is 10k. So e power 10k can be written as e power 5k into e power 5k. Already we have written what is e power 5k? That is 3. So when you substitute, so x is equal to x naught 3 into 3, that is 9x naught. That means after 10 hours, the number of bacteria will be present is 9x naught. That is 9 times the original amount of bacteria. Original amount means it is the initially. Initially how much it is there? So that 9 times of the original amount of bacteria. So you have to, using the 5 steps, we can solve the differential equation. Coming to the second problem, find the population of a city at any time t, given that the rate of increase of population is proportional to the population at that instant, and that in a period of 40 years, the population increased from 3 lakhs to 4 lakhs. So you have to find the population of a city at any time t. Okay, given that the rate of increase, so which word is important? The rate of increase. So this word is important, rate of increase of population. Okay, so first we have to denote the variable. So here I have denoted, let x be the population of a city at time t. What is x? It's a population. X be the population of a city at any time t. Now you see that the sentence, the rate of increase of population. So the population is denoted as x. The rate of increase is nothing but dx by dt. How it is? Proportional to the population at that instant. So dx by dt is proportional to the population. So the population is what? X at that time. Okay, so dx by dt is equal to k into x, and the proportionality symbol has to be removed. So you have to add constant k. So k is the constant of proportionality. So we form the differential equation. What is the next step? We have to solve it. Okay, so using variable separable method, so the x has to be brought to the left side in the denominator, and the dt will be taken to the right side, k dt. Okay, so you have to integrate on both the sides. The integral of dx by x is log x, k is a constant, integral dt is t plus c. So from that x is equal to e power kt plus c. So what will be the next step? You have to split this as e power kt into e power c. So e power c is a constant, so it can be taken as c. So x is equal to c e power kt. So second step is over. We have found the solution of the differential equation, that is the expression in terms of x and y. Here x and t. Okay, so that expression is in terms of x and t. What is x? It's a population. What is t? It's a time. And you see that the c and k are constant. So the population, it's depending on time. So we have written the expression in terms of x and t. So what is the third step? You have to apply the initial condition. So what is the initial condition? That is when t is equal to 0. So with no time, that is starting, t is equal to 0. Here can you write x is equal to x naught? You see the sentence. Read the sentence and write. In a period of 40 years, the population increased from 3 lakhs to 4 lakhs. So, 3 lakhs is the initial population. Then after 40 years, it is increased to 4 lakhs. So, first initially, that is when t is equal to 0, the population x is 3 lakhs. So, x and t has to be substituted in 1. So, what is x? It is 3 lakhs is equal to c e power. Why the power is 0? Because the power you are having t as 0 means e power 0. E power 0 is what? It is 1. So c is equal to 3 lakhs. So initial condition is over. Next, fourth step, you have to apply the given condition. See here, there is no other sentences. So again you just read the last one. In a period of 40 years, the population increased from 3 lakhs to 4 lakhs. So therefore, when after 40 years, the population is 4 lakhs. So when t is equal to 40, that is here time is number of years. So t is equal to 40, the population is 4 lakhs. So these two result has to be substituted in 1. Okay, so in the place of x, you have to substitute 4 lakhs is equal to, c value we have found what it is. It is 3 lakhs into e power. What is t? T is equal to 40. So e power 40k. So if we cancel the 0 or otherwise 4 lakhs divided by 3 lakhs. So all the zeros getting cancelled, you will have 4 by 3. That is equal to e power 40k. Okay, so here next one, the e when you take it to the next side, you have to find out that it will be for log. So log 4 by 3 is equal to 40k. From that your k is equal to this 40. When you bring it to the left side as 1 by 40 log of 4 by 3. So we have found the another constant k. We can have e power 40k, but so the next result when t is equal to 80 means So we can substitute, we can have e power 40k, then we can write e power 40k into e power 40k like that. But here we have to find the population of a city at any time t. So for that, here I have found k. Okay, so this k and c value has to be substituted in the first equation. So x has to be found, that is the population at any time t. So x is equal to, what is a c? 3 lakhs e power, what it is, k value is what? 1 by 40 log of 4 by 3 into t. So that t I have written as t by 40. So k into t, so t is when it is multiplied with t by 40 log of 4 by 3. Okay, see now it is in the form of m log a. So this t by 40 will go to the power. So it is e power log of 4 by 3 the whole power t by 40. And e and log, you see here, how it will be, how it is, e power t by 40 log of 4 by 3, isn't it? Okay, how it looks like, it is m log a. So m log a can be written as e power log of 4 by 3 to the power t by 40, because m log a is equal to log a power m. So on the exponential and the logarithmic inverse functions, so they are getting cancelled. So the answer is 4 by 3 to the power t by 40. So that only I have written here into 3 lakhs. That is your x. So the population at any time t is 3 lakhs into 4 by 3 the whole power t by 40. So the second problem we have completed, and we are moving to the third problem. The equation of the electromotive force for an electric circuit containing resistance and self inductance is E is equal to Ri plus L into di by dt, where E is the electromotive force is given to the circuit, R is the resistance, and L the coefficient of induction. So find the current I at time t when E is equal to 0. So consider the equation. So what is the equation? Here E is equal to Ri plus L into di by dt. So see that di by dt, it is a derivative, that is a first order derivative. So it is a first order differential equation. So the previous two problems we formed the differential equation, but in this problem it is given the differential equation. So you see that here, what is E? Electromotive force, it is given. So E is a constant. And what is R? R is the resistant, that also given to you in this problem. And L is the coefficient of induction. Okay, so E, R and L, they are nothing but constant in this problem. Okay, so you have to find I. What is I? I is the current. This current only, it varies depending on the time. So the current depends on T. So here I and T are the variables. I is depending on T. Okay, so E, R, L, they are constant. I is nothing but the current, it depends on T. So I and T are variables. So we have to write the relation in terms of I and T when E is equal to 0. Okay, take this Ri to the left side. E minus Ri is equal to L di by dt. Okay, so L we can brought it to the left side in the denominator is equal to di by dt. So di by dt, I is one variable, T is another variable. So we have to group the terms. So here You'll see that dt, it is in the denominator, it should be in the numerator. So when you bring it to the left side, it should be in the numerator. You see now, left side we didn't write dt. So E minus Ri divided by L, that is equal to di by dt. You see now, this dt I have brought it here, so it will be in the numerator dt, and here this L is in the denominator. When you bring it to the right side, L, and E minus Ri has to be brought to the denominator, so that is E minus Ri. Here what already is there, di, so we can write L by E minus Ri di is equal to dt. Okay, that only I have written. So see the left side, here you are having, it is the terms involving I. In the right side, the term having t. So we have separated the variables and you are going to integrate. So see that L is a constant, it is taken out, and here E minus Ri. So E is also constant. So E minus Ri. So when you integrate, di divided by E minus Ri is nothing but log of E minus Ri, and the coefficient of I is minus R. So we have to write minus L by R, that is L by minus R. So L is a constant and the coefficient of I is minus R. Usually the coefficient of x, after integration we will write in the denominator. Here you have to write the coefficient of I. What is it? Minus R. So it is written minus R, and it is in the form of dx by x. So integral dx by x is log, okay, log x. So therefore log of E minus Ri is equal to, what is the integral dt? It is t plus c. Okay, so the L by minus R has to be brought to the right side, and you have to multiply with both the terms. So it will become minus R by L into t minus R by L into c. So the log, if you brought to the right side, it will become e power. So e power minus RT by L minus RC by L. So they are in addition. So if you want to write multiplication, e power minus RT by L into e power minus RC by L. You look at this, RC is a constant. Okay, here C is the constant of integration. So R is a resistant and coefficient of induction, and C, everything is a constant. So the whole term can be taken as C. So it is C e power minus RT by L, that is equal to E minus Ri. So we got some expression in terms of I and T. So what is given that? We have to find the current when E is equal to 0. So when E is equal to 0, if we substitute, minus Ri is equal to C e power minus RT by L. So bring this minus R to the denominator. C by minus R. C already constant and R is also constant. So the whole constant has to be taken as C. So it's an arbitrary constant. So therefore I is equal to C e power minus RT by L. So the current we have written in terms of T. Okay. So we'll go to the problem number 4. So see now, the engine of a motor boat moving at 10 meter per second is shut off. Given that the retardation at any subsequent time, bracket, in the bracket it is given, after shutting off the engine equal to the velocity at that time. Find the velocity after 2 seconds of switching off the engine. Okay, so you see here the engine of a motor boat moving. So the motor boat is moving. So at the speed 10 meter per second. So why I am saying 10 meter per second? So per second it is moving 10 meter. So it is nothing but the speed of the motor boat is shut off. So the engine of a motorboat is shut off. It is moving, first starting, it is moving at the speed 10 meter per second. So 10 meter per second is the velocity. Okay. Given that the retardation, so see the word, the retardation at any subsequent time after shutting off the engine. So after shutting off the engine, the retardation at any time t, the retardation is nothing but it is the negative acceleration. Okay, the decrease of in the velocity, the decrease in the velocity with respect to time, or we can call it as negative acceleration. So acceleration, how it will be? It is the rate of change of velocity. So the rate of change of velocity is negative, that is called the retardation. Okay, that retardation at any subsequent time is equal to the velocity at that time. So what is given that? The retardation at any time t is equal to the velocity at that time. So what I have said retardation? It's a negative acceleration. So I have written minus here. Acceleration, the rate of change of velocity. What is v? V is the velocity. The rate of change of velocity is nothing but dv by dt. That is equal to velocity. So it is equal to v. So here we formed the differential equation. Okay. So here we have to separate the variables. Here you are having dv, it should be in the numerator. So bring this v to the denominator in the left side. That is equal to minus dt. So dt is in the denominator here left side. So it will be brought to the right side. So minus dt. So integrate on both the sides. So integral dv by v is equal to integral minus dt. So here your integration answer is log v is equal to minus t plus c. So v is equal to e power minus t plus c. So how it can be written in multiplication? E power minus t into e power c. E power c is a constant, so it can be denoted as c. So v is equal to c e power minus t. So from the differential equation we solve and we have found the expression in terms of v and t. V is velocity, t is time. So it's an expression written in terms of v and t. So what's the third step you have to do? You have to apply the initial condition. So when t is equal to 0, t is equal to 0 means after shutting off the engine. So that is t is equal to 0. What is the initial velocity? It is 10 meter per second because the motor boat is moving 10 meter per second. That only shutting off. After that only the retardation is equal to the velocity. So therefore when t is equal to 0, the initial velocity is 10 meter per second. It has to be substituted in this equation. So in the place of v, it is 10 is written is equal to c e power. In the place of t as 0. So e power minus 0. So e power 0. E power 0 is 1. So c is equal to 10. So after finding c, you substitute in the first equation. So v is equal to 10 e power minus t. And you see that. So next, fourth step, we have to apply the given condition. So nothing is given in that except first starting it is 10 meter per second. So we have taken as the initial velocity. Then from the second sentence we formed the differential equation and solved it. And here directly the question is given. Find the velocity after 2 seconds of switching off the engine. You have to find the velocity. So velocity means v has to be found after 2 seconds. So when t is equal to 2, you have to find what is v. When v is equal to what? When t is equal to 2. So you substitute here. V is equal to 10 e power minus 2. So e power minus 2, bring it down, it is e squared. So the velocity after 2 seconds is 10 by e squared meter per second. Okay, coming to the problem number 5. See that, suppose a person deposits 10,000 in a bank account at the rate of 5% per annum compounded continuously. How much money will be in his bank account 18 months later? Okay, you see, suppose a person deposit 10,000 in a bank account. So 10,000 is a principal amount. So at the rate of 5% per annum compounded continuously. So the rate of interest is 5% per annum. So first I declared, let x be the principal amount at time t. What is x? X be the principal amount at time t. Okay, so the rate of change of the principal amount according to the time, that is dx by dt, that is equal to, here what is given, the rate of 5% per annum, that is 5% of x. So this is the rate of interest is equal to 5% of the principal amount. So here dx by dt is equal to 5 by 100 into x. So 5 by 100 can be written as 0.05 dt. So here we formed the differential equation and we have to solve it. So this x will come to the denominator in the left side and 5 by 100 can be written as 0.05 into dt. So we have separated the variables and we are going to integrate. So here dx by x is nothing but log x is equal to 0.05 is a constant. So integral dt is t plus c. C is the constant of integration. So therefore you are getting log x is equal to 0.05t plus c. So x is equal to e power 0.05t plus c. How it will be written? E power 0.05t into e power c. So the whole e power c can be written as c. It's an arbitrary constant. So we formed the equation. So second step is over. Next, third step, what you have to do? You have to apply the initial condition. So when t is equal to 0, that is starting initially, how much principal is deposited? It is the person deposit, how much it is? It is 10,000. So when t is equal to 0, the principal amount, that is x, is 10,000. So this x has to be substituted as 10,000 is equal to c into e power, what is it? T as 0. So e power 0. So c is equal to 10,000. So this has to be substituted in this equation and you have to call this as 2. So initial condition is over and you have to apply the given condition. So see the constant c and k already it is given. So you need not apply here. Apply the initial condition. You have to go to the third sentence. How much money will be in his bank account 18 months later? Okay, 18 months later. So here when t is equal to 18 months, you have to find what is x. Okay, 18 months. So see here you have to write in terms of years because the rate of interest is per annum. So per year only we have calculated. So 18 months is nothing but 1.5 years. This 1.5 years can be written as 3 by 2 years. Okay, so t is equal to 3 by 2. You have to find what is x. So substitute in this second equation. X is equal to 10,000 e power 0.05 into 3 by 2. If you simplify, 0.05 into 3 is 0.15. 0.15 divided by 2. So that is equal to 0. So 3 into, you see now, 3 into 0.5 is 0.15 divided by 2. If you simplify, it is 0.075. So after 18 months, the money will be 10,000 into e power 0.075. So next we are moving to the problem number 6. Assume that the rate at which radioactive nuclei decay is proportional to the number of such nuclei that are present in a given sample. In a certain sample, 10% of the original number of radioactive nuclei have undergone disintegration in a period of 100 years. What percentage of the original radioactive nuclei will remain after 1000 years? Okay, so first I declare the variable x. X is nothing but the number of nuclei present at time t. What is x? X be the number of nuclei present at time t. See the first sentence, assume that the rate, this word is important, the rate at which radioactive nuclei decay, okay, is proportional to the rate at which radioactive nuclei decay. So the rate of change in the amount of nuclei. So that is nothing but dx by dt. How it is? It is proportional to the number of such nuclei that are present. So number of nuclei present at time t is x. So dx by dt is proportional to x. And dx by dt is equal to minus kx. So k is the constant of proportionality. Here why I have written minus means it is reduced. So it is decay. It is given nuclei decay. So that's why it is reduced. So here I have written minus symbol. You need not write minus. You can write plus also. Okay. So we formed the differential equation and you have to solve it, the second step. So you have to separate the variables. So and you have to integrate. So here the same thing, integral dx by x is log x is equal to minus kt plus c. So x is equal to e power minus kt plus c. If you split us in multiplication, e power minus kt into e power c. E power c is a constant, so it can be taken as c. So x is equal to c e power minus kt. So second step is over. We have written the expression. We have solved the differential equation and wrote the expression in terms of x and t. X is depending on t. So c and k are constants. So x is the number of nuclei and t is the time. So third step, you have to apply the initial condition. You see that in a sample, 10% of the original number of radioactive nuclei have undergone disintegration in a period of 100 years. Okay, after 100 years, 10% is destroyed, it is decay. Okay, so you see now first initially we have to take when t is equal to 0. When t is equal to 0, we have to take the number of nuclei is x naught. So you have to substitute in the first equation. So x naught is equal to c e power 0. So c is equal to x naught. So when you substitute, you got this equation. Now you apply the given condition. What is the given condition? You see that 10% of the original number, that original number we have taken as initially, that is x naught, of radioactive nuclei have undergone disintegration in a period of 100 years. So on the 100 years, after 100 years, how much amount is remaining? Okay, how much is undergone disintegration, how much is remaining? Here they have said 10% of the original number have undergone disintegration. So 10% is gone. Okay, so in disintegration it is gone 10%. Up here we have taken x be the number of nuclei present. So how much will be present after 100 years? So see now it is 90% of x naught. So this is the original amount, that is the initial amount. That is when t is equal to 100. So after 100 years, what is x? X is the number of nuclei present. 10% of nuclei have undergone disintegration. It is gone. So how much will be present after 100 years? It is 90% of x naught. So you have to substitute in the second equation. So in the place of x, 90% of x naught is equal to x naught e power minus, what is k? K we don't know. So t is 100. So minus 100k. So 90% can be written as 90 by 100 into x naught is equal to x naught. This can be written as e power minus k to the power 100. Okay. So to do the calculation, I have written like this. Okay. So x naught getting cancelled, and 0 is cancelled with 90 and 100. So it is 9 by 10. So e power minus k to the power 100. Okay. So here e power minus k can be written as 9 by 10 the whole power 1 by 100. So the power here, if you raise to the power 1 by 100, here also 100 into 1 by 100, it is getting cancelled. So therefore e power minus k is equal to 9 by 10 the whole power 1 by 100. So this is the given condition. And what is asked? So you see that in the question, what percentage of the original radioactive nuclei will remain? So here what is asked? Will remain. How much will be present? So they didn't ask how much is gone. So how much is present after 1000 years? So when t is equal to 1000, when t is equal to 1000, you have to find what is x. To find what? X is equal to what? When t is equal to 1000. So it has to be substituted in the second equation. So what is the second equation? X is equal to x naught e power minus k into t. Here x has to be found. So x is equal to x naught e power minus k. What is your t now? 1000. Okay. So it can be written as e power minus k the whole to the power 1000. What we have found e power minus k? We have found e power minus k is 9 by 10 the whole to the power 1 by 100. So it is substituted. And if you apply the power 1000 by 100, that is 10. So that is 9 to the power 10 by 10 to the power 10 into x naught. They are asking in terms of percentage. So this 10 power 10 can be written as 10 power 8 into 100. Okay. So that 100 I have written here. Okay. So if it is divided by 90 by 100 as 90%. So therefore this much percentage, how much percentage? 9 to the power 10 divided by 10 to the power 8 of x naught percentage will remain after 1000 years. You see now here 10 power 10. So the question in terms of percentage. So percentage means it has to be divided by 100. So therefore 10 power 8 I kept as it is, and 10 power 2 is written as 100. So 90 by 100 is nothing but 90%. So therefore this much divided by 100 is this much percentage. So 9 to the power 10 divided by 10 to the power 8 x naught percentage will remain after 1000 years. Thank you, students.